And there is a nice slide from the Jans LeCun's presentation. Yeah, when and he's actually he built a convolutional neural networks. Did you heard about? Did you use convolutional neural networks? It's a specific type of neural networks for image recognition and image processing. And here in the green, you see that what we could do with the current technologies like neural networks, and in red, what we don't actually is not reachable yet. And my favorite is that what you could do. There is a what you could do. There is a useful but stupid chatbots. And remember, when you build your application, yeah, and you want to build a chatbot, remember this, that you could build a useful but stupid chatbot. And what you can't is have a smart chatbot or household robots. I remember that 2 years ago, I looked for some household robot. My dream is that you know this hand manipulation, this manipulator. Imagine that you have two of these hands manipulation put in kitchen, then feed the AI with a recipe, and it cook for you. Yeah, and then find a robot that could do cook for you, and only one dish. It's a boiled eggs, not boiled but scrambled eggs, and the cost of this robot is $400,000. So a little bit too expensive for scrambled egg, cooking scrambled eggs. So that keep in mind this, and of course, uh, what is the next? What we need to achieve in machine intelligence is that how to use small data and use causality. And if we look at the current state and the like perspective of AI, we could say that there are three waves of AI. The first wave is something that we uh, had before, like 2008, something like that. That they're more rule based and something like that. Then the second wave, neural networks, deep learning, and deep learning it's for we are talking about deep learning where we use neural networks with more than 3 layers in it. And the third wave we just approaching is something like cognitive architecture. And if you look at cognitive architecture, it looks more like human architecture, when we have a input, output, some processing, parsing, short-term memory, long-term memory, semantic memory, learning capabilities, and so it should be more complicated. It's not just a one model. Today we will look at just one model. Today we will look more on narrow AI. Yeah, narrow AI. And if we think about this narrow AI and compare AI versus human, yeah, then actually this AI is very specialized. General artificial intelligence is the next level we are thinking about. It doesn't exist. There's no. And if we look at the human, it's also actually very narrow. We think that we are so general purpose, so but we are actually so narrow. And before we're talking about small data, and remember this, remember I said that about narrow AI and how good we are, for example, for recognizing pictures. So it's one of the cognitive services. You you think how good you are. If you talk about AI, we say that AI is a good of recognizing pictures, like say that, that there is a dog in this picture, so recognize dog. How you think how good you are at recognizing dog in the picture? I see confident faces that you are very confident, but let's check it out. Let's check it out how good you are at. There is a nice best example that Chihuahua or muffin. Okay, let's go. Oh, I see you are not so confident anymore. Yeah, and so sometimes it's not easy even for human. Yeah, and if it's like fastly moving row of images, so we will make for these images 15% or 20% error. So it's quite high. So it's not easy for even for us. And let's talk about these two things that we could use additionally before we go to real machine learning and AI. The first is a small data. What it means, small data. And actually, it's a machine teaching. There is a discipline that is just rising, and Microsoft is one of the companies who are driving a lot of for it. And uh, usually, you know about machine learning, but there is a machine teaching. And the idea comes that, for example, if you classify text, it's easier that you as a human you use some tools, and there is a Microsoft machine teaching tool, and you use this tool and help machines to understand, like the green ones are true positives and the um, red ones are true negatives, and you see what machine detected as a false or negative, and you could correct it. And I will run a video and will tell you without a sound behind. So it's a product that called Pickle. Pickle. It's just in preview. It's not available yet, but we will look at how it works. And there is idea that Pickle will be included in LUIS sometime in spring this year. This is the idea that you could teach algorithm and it will be faster. You need less data. I will look where we have this demo of the Pickle tool, just to have impression. Imagine that you have the project here and open it and ready to train. Yeah, it's working. And now you get this scoring. It looks looks differently than usual machine learning models and training approaches. Yeah, different options, and main purpose that we could um, train it for entity recognition in this example, and help machine to work better. So we also give it some. This is elements of reinforcement learning, and we could say that yeah, that's good, well done, machine, or no, it's not well done, do this, and so on. And it's a lot faster. For example, if you don't have enough data, maybe you will never build a machine learning model for entity classification or your data sample. But with machine teaching, it will be possible for you to build one. Any questions so far, comments? Just whoa or something? No? Okay. Did you see it before, machine teaching? So be ready. If you work in machine learning field, machine teaching is something. Start Bing it right now, and look some materials about it. Next thing you need to, and the machine teaching will be needed for you when you work with a small data. Next step, imagine that you don't have any data. Can you do analysis without data? You say no, but actually you can. That is how humans think, and it's a causality. And if we talk about causality, it's a very important phenomena. And actually, causality is the way how humans think. Machines don't think in causality. Machine thinks in correlation. Like in this picture, you see there is a correlation between Nobel Prize laureates in a country and chocolate consumption. And you see clear correlation. You see that there is a positive correlation. It means the more you consume chocolate, the more Nobel Prize laureates you will have. Yes, right? Wrong. Yeah, and we as a humans we understand immediately. But for machine, if you give this data to machine, it will start to feed you with chocolate, yeah, immediately. And that is um, if yeah, if we talk about causality, we understand that it, there is a little bit different causality for this Nobel Prize laureates in chocolate consumption. And what is actually causality? That is something that is related, that influences some as a factor. Like here you see this R reinforcement and B balancing. And the usual causality is like if mm, that that something for sure will cause other activity. And in causality, there are another award winner of Turing Award. It's Judea Pearl. Also, you need to know him in machine learning AI field. He's invented Bayesian networks. If you somewhere seen Bayesian networks, the probabilistic build networks, so he invented them. He invented it. Judea Pearl. And this is nice picture because it explains actually level of consciousness or level of thinking that we could expect from machines and animals. And if you see that animals and machines on the level one, they can think, they can see associations and can detect associations. It means that if a cat can see how the mouse moves and then catch it, and same machine could analyze data and find all the associations, correlations, we say correlations. But cat, even in 1,000 years of evolution, didn't figure out that you could get a cheese from somewhere, put it somewhere, wait for mouse, and catch it. Thousands of years, but no results. And that is a level of machines and animals. Next level, number two, is intervention. It is how to model a situation. If you will rise a price, increase price twice, what will happen? If you will like stand up now and start drawing with marker on this projection, what will happen? Yeah? And this is actually not accessible for machines and animals. And the third super level is that you could build imaginary uh, imaginary uh, field in your mind, put known and unknown, existing and non-existent objects, and iterate with them together. So it's only available for humans. That is what maybe sometimes we expect from this general artificial intelligence. But according to Judea Pearl, because machines and animals don't think in causality, yeah, it's not accessible for them. And if we look at the causal diagram, how the causal diagram could look like, there is one of the causal diagrams I draw for uh, organization, for selling organization. So, and there you see that on the top level there is a buy, why the clients buy, and then you answer on each level why. And that is how it, to understand the concept of why or this causality data in any kind of data, any amount of data, you could answer to several questions like how many, how much, when, who, but you can't find in data answer to question why our customers are not buying, or why something happening. This is not, you can't explain it with only with data, because it requires causality. And that's very interesting. And here's another diagram of causal diagram I built for Emergent. And you could see here, I explain the building the people capital. And we are uh, in these days we are talking about a lot of about this. So we think that we need a more people capital. It means clever people, knowledge, and so on. And then if I ask you how or why people capital is growing, And here we see that there is some that build others and share knowledge, or initiatives helping solve problems and things like that. And why? Because value knowledge to share. There is a value. The people have value valuable knowledge to share. And how they get it? Because they learn constantly, and they learn from any experience. And then it's a question why the people learn constantly. And there are, because if we look at today's learning habits, the people who learn constantly learn in their spare time. They are not learning at work. They learn in their spare time. Like you today, you you spend your free time here. Yeah. And the answer is a cause for that, why you are here, because you enjoy what you are doing. That is how why people try to play guitar or whatever, because they enjoy it. And the same for any kind of knowledge. And you can't find it in the data. You just could build a causal relation, causal associations, and only humans could do that. And there is one joke I like, that what will happen when everything will be automated, and then the picture of future automated factory, and in a future automated factory there will be two employees, dog and human, and they main only one there's only one task for human, feed the dog, and only task for dog, watch that people the human is not touching any buttons. So that is an automated future factory. Yeah, and what machine learning can do, a lot of things, and we will talk about most of them today. Okay, and now let's continue with cognitive services. And the cognitive services from Microsoft, uh, it's a pre-built AI, and if in 1955, like 70 years ago, scientists talked that AI is understanding concepts and could be creative, can be creative, and so on. Then, starting 2012, the definition of AI is more like could imitate some of human skills. So, vision, speech, language, knowledge, and search, and things like that. And let's start with some of these cognitive services, and I will show you one. This how old. It's actually application that build using this Vision API, using Vision API that recognizes images and can detect humans in picture, number of them, age, and gender. Actually, it can do even more. So you could open it in your computers if you want. If you want, its address is how-old.net, and here we can find or use your own picture from last corporate event. I will search for some. Oh, yeah, and there's a Mr. President here. How old he's here? Any bets? Ding. Yeah, almost 75, and we see that it actually Alex will show you in details in a couple of minutes, but it shows like it detects the position of face. It could detect face position, could even detect eye position, so where the people this man in the picture is looking at, and we see that it detects gender and age. Let's try another. Yeah, yeah, it will show another age. Yeah, yeah. Let's 76, but it could be, for example, this probably is the same, but it's 56. So I could say that I did a lot of tries of this. The age is not very accurate because it depends on picture, some quality of the picture, and the light, and so on. And this, I could say that this age quite It's not very super accurate, but the gender is more accurate. Let's try some picture with more guys here. Couldn't detect any faces. This one. Hoppa. Yeah, and we see that that age probably. We see this. that This guy is definitely not much older than this other guys. Yeah, that is how we see. But if we increase size of this picture, we could detect more faces and so on. Let's go back. And yeah, before and let's start with this demo. Let's start with Face API. And to run this Face API, we will straight. Do you need something for Face API? Azure service? Yeah. Okay, and we will start with how to start this API. Use this Face API and build in your application. In Azure, we need to create this cognitive service, and this Face API. Just say create, and there the use, and I could use any location, but maybe for demo it's better to um, use US location. There are two pricing tiers. Be careful with that because, as you see, there could be a 10 calls per second and is as zero call, which is paid call, and it could. We built some examples, and it's easy to run to spend $100 per day if you like looking at trying to recognize if you use video for recognition face recognition as it's not hard to spend $100 per day or a couple of days. Let's create a um, group. Okay, and now while it's creating, let's switch to Alex. I'm stop sharing. Um, yeah, so basically, what is the essence of that? Wait, I will do your microphone.
Yeah, thanks. Uh, what is the essence of the API is that it receives some encoded photographs, images, and it tries to find faces in the images and sends back the locations and the detected emotions of the people in the images if it has found any. I'm going to be using those faces in the demo. And by the way, those faces are not real. They are generated using neural networks. So none of the people that you see right here exist. And yeah, so I'm going to be using Python for that. Here I have a little script, and if you want to do it yourself, you basically um, have to go to the Microsoft platform and get to the cognitive service. Basically, you can just Google Microsoft Cognitive Services Face, and it will return to you the Face API webpage. And there, from documentation, you can find a sample code from for your beloved Python or .NET that you can use to basically do the same experiment. I have already used the code. I'm going to be using Jupyter Lab for that, and yeah, Aldous just sent me the key that is needed for the.
And key is in this Azure, when I generate this Azure Face service, you have a key there. So you need this key to access service.
Yep. And I guess the URL is going to be the same.
What URL do you have?
North Europe, actually.
Oh.
Yeah, I guess I'm going to need. Yeah. So technically, what's going to happen right now? The script is really easy. I'm just going to send a post request to the Face API, and I'm going to receive a response that is coded in JSON with the information about faces. Now, no machine learning is going to be done in that script. Yep. Thanks. Oh, that's not it. There is a moment. Um, mm,
Then you need to use this US. I will look at the script.
yeah, perhaps. Yeah, so no machine learning is going to be done in that script. All the machine learning has been done by the Microsoft, and all the services that we are using already use trained machine learning models, and we're just going to send to the models the inputs. In our case, this it's going to be the photographs, and we're going to receive the response from the trained machine learning models. And yes, so basically, technically, it's quite easy given the sample code, and yeah, I guess all this. I'm afraid that's not it. There is a
It should
one
be
moment.
West US.
There should there should be a route in the end.
It's just different.
Oh,
Yeah, you need to just change the region.
uh,
westapi.api.cognitive.microsoft.com instead of North Europe.
oh, okay. It just changed it. It's not popped up there.
Yeah.
Moment.
Oh, you need to just provide the region.
Mhm. Yeah, so on the top you can see there are several constants that are used here. So that's the image path, that's the path to the photograph in the project folder. The subscription key is the key needed to access the service. Face API URL is the URL to which we are going to send our request. Some headers that are needed for the request, and parameters. And
Yeah, and we're using a free tier, this F0, and it allows you to run 30,000 calls per month.
yeah, so then also that's nothing really difficult. We're reading the image from disk, then we're encoding the image as a string because we can't send a photograph, we can send an array of symbols. Then we send a request to the API and receive a response, and get a structured response in the JSON format. Yep. And then because there are a lot of faces, we need to loop through them, and for each face, we're just going to get the locations of the faces and the emotions that were detected. And here in this bit of code, I'm also drawing the rectangles for the faces and writing down the emotions that were found. One moment, something's not right. Thinking this is must be integer. Okay. Okay, Aldis, I guess that's not the valid subscription key. or not valid URL, because we were using .api.cognitive.microsoft, whatever, but you send the
No, you
dev
need
code,
to use this API.
the one that you have sent, yes?
No. But West US.
Yes, I just changed the North Europe to West US, but I believe that could also be the case. One moment.
Keys.
Okay,
Keys one.
okay, try number 2.
Then try this.
Nope. Isn't there a Could it be not in the portal, but space.
Try API console.
Yeah. Okay, perhaps sometime in the near future we're going to succeed, but I have a saved photograph of the faces that were detected. And yeah, we can pretend that those were returned by the service. So yeah, this is those are different faces, but I have tried to find a like a collage of different emotions, and yeah, you can see that it detects emotions like happiness, fear, anger, surprise, disgust, and there are I believe 8 total emotions that it can find. And of course, if you look closely, then perhaps the I guess the fifth photo from the top is you wouldn't really call surprise, but that's also quite subjective because not all people would consolidate on what surprise means or what anger means, and the fact that this is done automatically with the machine is quite powerful. And yeah, if we can get the right URL, you're going to see that that is actually quite fast. So like you can do that industrially and get uh, we were, for example, using video streams to do the same thing, and we were sending each frame to the service and returning to detect the faces and returning the locations with the emotions, and we were able to stream videos with 24 frames per second. So, mm, nope, I guess that's not not that. There was one moment.
You should go to this SQS.
I have tried that. The community. Oh. Hmm. Okay, I guess I'm gonna try one more time with the
The previous location was North Europe, yeah?
yeah
North.
North Europe. Yes. That that. Oh, here we go. Yep. So yeah, where we left off. So here, that's a bit of code that is trying every face, looking at every face and drawing rectangles above the face and the emotions above the head of the person. And here we are just going to draw the final picture. And yep, so that's basically what I was talking about. That's the original picture that I was showing, and yeah, you can see that. Of course, I picked the ideal case where all of the people are looking in the camera, and all of the people have like standardized the width and height of the frame. So this is the ideal case, and of course, that is going to work. But that also even that is quite an impressive achievement for a machine learning algorithm, because of course if you are watching through for example security video feed, not all human would also be able to for example detect detect and tell the emotions of the people that are passing through. But just as any of you here could tell the emotions of the people in the frame, machine could do that too. Yeah, and as you have seen, that doesn't take quite a lot of time. Uh, that happens here, and that
And just as an idea, what you could try on, imagine that
yeah.
you could use a cognitive services, face recognition to build in your application to detect is a person focused on your application currently, because you could detect a position here, and so you could say that, oh, it's focused, let's show this or that.
Yeah. So and you can use that
Yeah,
a
even
lot of.
we had idea and tried it. Imagine you have a camera here, and camera is like filming all of you, and with cognitive services, face recognition, you could say that who is watching in phone, who is not watching on the screen, but who is like watching, looking in the phone. So you could do it with this service.
Um, yeah. So and the fact that the service is using the HTTP request for the consumption of the results, that means you can use that almost anywhere. You can use that in your web applications. You can use them in mobile applications. All you need is internet access. And for solutions that are on premise, there are other solutions. But if you are willing to deal with the cloud services, then this is really useful for you.
Okay, question now. You are like big fans of Microsoft and developers. If you need it on premise, what to do? Now we are showing you Azure Cloud Service. If you want to run it on premise, what to do? Can you do it? How to solve it? Yeah, okay. Yeah, you can deploy the cognitive services in container. And you don't have to pay for it. You need to pay for it. It's not but it totally free of charge. Hmm? If it's run on your machine somewhere, it should be charged a bit less, like rather than probably. I don't know pricing for this container versions, but you need some connection for licensing. But otherwise, it runs on your computer, so using container. And I'm curious about emotion detection in video. So you told that you treated like every frame into
That was that was the first approach, of course.
try some other.
Yeah, we have tried every second frame, every third frame. We have tried approximating frames in between, and yeah, that worked quite nice. But of course, that's not state of the art solution. I believe that there are more optimal solutions for working with video feed, but that was just like an experiment. We needed to test out the service, and that was the first thing that came in mind. Sorry.
Which one worked the best?
In the end, we have just used the same service, but we were using every, I believe, third or fourth frame. It dependent on the like nature of the video footage that we're looking at. If people are running around, of course, you need to do that more frequently. If people are sitting still, like for example, in a chair and they're not moving a lot, so their face location does not really change a lot. You can deal with like every third frame or every fourth frame. Yeah, and that makes quite an impact on your bill in Microsoft Azure, because yeah, so that's basically 3 or 4 times less um, of the requests every second.
Yeah, and I think that like suggestion or advice is if you are building your application and you think you need something like that, some of cognitive service, take cognitive service and use when you build it. And if it works fine and it's like the next killer app for everything, you will train your own network or face recognition. Multiple accounts, for every employee. Yeah, it's easier to train your own account, your own network for if it's needed. So again, it's I think it's best for development part. When you develop something, use this because it's you don't need to do anything. It's in the minutes you have it. And if you will need it for production, and you say that in your scenario cognitive service is too expensive, train your own network, find a free network for that, and deploy and use it.
Yep.
Let's make a break. Yeah, let's continue and we will show you another cognitive service. It will be a translation service. Again, let's create in Azure first and just create a new resource. It will be translate to text. Create. Yeah, a lot of pricing tiers we see. Oh, nice. 2C3 pricing tier with 250 million characters. Let's try permitted 2 million characters per month. Let's use this one. Subdominate. Pa. And as in previous example, I will create the keys and stuff and will send it to Alex. We see that it creates quite fast. In a minute or so, we will get it. Deploying. Ready. Okay, I have all the keys and stuff. And I'm just giving you microphone.
Here we go. Yeah, so now I'm going to again put the new generated key in the script. Right now we're going to demonstrate the is it even what? Yeah. What's going on? One moment. The machine translation service. It's called Translator Text API. Once again, as in with every cognitive service, there is a documentation where you can find a sample code with the API call for different languages. Somewhere here, yeah. So it gives an option of Java, Python, Node, even Go, and C#. We're going to use Python in our case. So we're going to change the subscription key to the newly generated one. Again, the script is quite easy. No machine learning done here, just importing necessary libraries, setting the subscription key, setting some parameters. I hope that the old URL is going to work. And constructing the headers for the API call. And here is the text that we're going to translate. This is the text that should be translated. Did it work? Put it in the body of the request. And here at the top, at parameters, you can see that I have specified 3 languages. I hope you can see that. If you don't, it says %2 equals LV, that's Latvian, then VE, that's German, and the IT, that's Italian. If you have some suggestions, we can try to translate to some other language so you can rate the translation quality if you can suggest something else. Sorry? Okay. Yep. Oh, sorry. Yep. Mm-hmm. And
Can you say something in Danish and Dominic so people type?
I guess you can rate the translation quality for that. I'm not sure that I'm going to be able to write in Danish quite well. Yeah. So again, that's the message to be translated. Here we're sending a request and receiving the response. And here, okay, the target language is not valid actually, so that's not DK. So let's search for Danish because. Oh, okay, we can try DA. There was a list of all the DE or DA. Okay, there is a list of all supported languages. One moment. Is it DE? Okay. Da. Okay, try number 4. Yeah, here you go. So yeah, here we receive a response with 4 languages. That's the Latvian one. You can rate that one. I don't really speak German or Italian, so perhaps some of you can rate that. I don't really speak Danish as well, so you can rate this one. Is it at least remotely correct? Remotely, okay, so that's nice. So the list of available languages is really huge. You can see that there is hundreds of different languages. Those are all the languages that the translator text API supports. And yes, once again, all machine learning has been done beforehand, and the translator text API is just storing the trained model, and we're using it through a request. So yeah, perhaps that is the essence of that service. Perhaps you have any questions about that?
Pretty straightforward, I think.
Yep, I thought so.
So what you do, how you could use it, or how we in some use cases use it. For example, we built a prototype of chatbot for Switzerland and for the service, and they have a lot of countries, clients on different countries, and on backend they had a knowledge base, but only in English. Imagine you have only English knowledge base, and you want to provide a service when the people are asking in their own language, and receive answer from knowledge base in their own language. So you just put that translation. Someone writes in Swedish, for example, you automatically translate it to English, search in knowledge base, get an answer in English, translate to Swedish, and voila, answer in Swedish. You'd and it's so easy. You can't believe it. Now I will tell you the same example in German. That request in German, you translate in English, get an answer. Joking. Yeah, it's pretty straightforward. So let's move to the next example, and it will be a custom vision. Are you familiar with customvision.ai? It's a cognitive service, but it's with quite rich user interface. If you just write customvision.ai, so the idea behind customvision.ai is that you create that you create project, the custom vision AI on in address bar. Yeah, because I'm logged in, so yeah, this nice picture. So you could train your own model. For example, if you if you want to for example, if you want to recognize some products or some faces, you could, if you have 5 or more pictures of it, you could put it here and train. There is a behind that there is a neural network that will, if you go a little bit down, there is a schema. So you provide 5 images of the one entity, then train it, and it could show you the score for the new image. I know that Remy actually is playing with that. You know, this self-service points, and then you put the products like oranges or apples. They are working that they could recognize that these are really apples or tomatoes, and they are playing this custom vision service, and it works pretty well. So we will show you the how it works, and I will build needed resources. Yeah, for that.
Yeah, so I can tell a little bit about that demonstration. So
And you could do the training from user interface from this. I will show this user interface how
yeah.
it looks. So like this fully functional GUI, or you could do it the training and deploying and using from the code. So we will show you a blended demo where Alex will train model and deploy model from the code, and then we will try it out from the UI.
Mhm. Yeah, so we're going to try to classify two types of objects. Those are grapefruits and lemons. Really trivial example, but it's quite nice to prove the point of like the concept. So I have 10 different pictures of grapefruit, but all of them are, of course, as you can see, quite standardized. Those are one or two or three fruits on a white background. The same goes for lemons. Of course, if we're talking about the example with Rimi, as Aldis said, it's a little bit more complex because there is an uncertain amount of fruit and there is a lot more objects. But the background is still going to be the same because the camera is standing still.
Yeah, I'm creating now cognitive service in Azure.
Yeah. So we're going to use those 10 pictures to train the model to classify grapefruit, and those 10 images to train the model to classify lemons. And then we're going to try to classify some different pictures of lemons. For example, that one.
No, I will take some picture from internet.
Yeah. This is going to choose like one random picture from like Google Images, or I'm sorry, Bing Images. I was trying to say, yeah. So the code.
Nice, it was nice.
Yeah. Again, the documentation for custom vision provides sample code for different languages, so you can try that at home if you are willing to, or you can try that right now if you are feeling adventurous. And the code is also quite simple. There are a little bit more imports, and those are not standard libraries. Those you have to install on Python. And okay, is that a training key you have sent me?
Training key.
Yep. Then we're going to set all the parameters. Here it is a little bit more complicated because you have different training keys and prediction keys, also the resources ID, and of course the endpoint, which is the URL where we're going to send the data. And I guess you also, what's that? That is the same.
Sorry? No, this is the prediction key.
I guess we're not going to be needing that, but okay. Can you also send the prediction resource ID? That the long link.
Yeah.
Yeah. So, and then, here we go. Okay, that's the last link we're going to put in, and put it in here. Yeah. So, forgot the libraries. Okay, so then quite simple. We're creating a new project called my new project COP for community of practice. It will take some time because that is a new project, and we see an error in request. Something, new connection error. Well, to establish a new connection. Is the endpoint the same?
No, it's different. No, it's not easy to be a low-code machine learning developer.
Okay. So taking the endpoint, and here you go. Yep, here we go. One more try, creating a new project. Yep, in some 2 seconds it was done. Then we're going to set the tags. Tags are the classes that we're going to predict. So in our case, that is grapefruit and lemon. Then we're just going to loop through all the images. So that, those are 10 images of the grapefruit and 10 images of the lemons, and upload them to the custom vision platform. It also shouldn't necessarily be too long, just 20 images, not really high resolution. Yep, it is done. And yep, here is the last step. Here is training. So a little really fast conceptually about machine learning. So there are two phases. There is training phase and there is a let's say prediction or classification phase. During the training phase, the machine learning model, which is basically a mathematical algorithm, is going to try to is going to try to distinguish the most important differences between the classes that were provided to the model, and we have two of them. So the model has 10 images of grapefruit and 10 images of lemons. It is going to try to distinguish the most important things that are different from grapefruits and lemons. And in the second phase, which is like classification or prediction phase, when it receives a new image, it is going to try to use the information that it has learned as in machine learning during the training phase to predict what is the new image, what is the class of the new image, because it has not seen it. And yeah, because we have only 20 images, that also wouldn't be really long. Some 5-10 seconds it should be. Yep, so the training is complete and we're done. So there is a possibility to do the whole process from the script with the classifications and predictions, but we have trained the new model in a new project, and now all this is going to show the user interface that the yeah, stop sharing. Yep. That the custom vision API. Oh, that's not that.
Yeah, and now this is a GUI of Custom Vision. I just refresh it, and you will see that there's a button that we, of course, could create a project from the scratch and do the same stuff like upload images. And this is a project created by Alex. So if I go inside it, I will see a lot of stuff like all the images, tags, target images. There is a train button. So as a low-code machine learning developer, I use interface like that. Alex use the code. And we could create many projects. So we could look at performance, how good this model is, how good predictions are. But let's just test it out. And here we could provide an image or provide some link to image, and it will classify it. So let's use this one. What do you think, Alex?
Let's try.
This one.
Nobody knows.
Copy.
You can already see that the image is not standardized like the images that were used for training, so it doesn't have white background. It is hanging from the branches of a yeah.
And now we see that lemon, it classifies as a lemon 37% probability and as a grapefruit 0.8. So not very high for the lemon. Let's try another picture. Let's try babalam. This one. Yep. Thinking. Oh,
looks like that's a hard lemon.
it's potato. Maybe it's yellow potato. Maybe it's just very big image. I don't know.
Yeah, maybe it is struggling with the resolution of the image because it actually is a lot bigger than the images that were used for training.
Invalid source. Okay. Let's try another one. This one. Oh!
Yep.
Holy moly, look at that. Lemon, 99% accuracy, probability.
Most
So,
certainly that's a lemon.
yeah, that is how you could use, and the same probabilities you will have in your application. For example, if you send some image to your model, it will return your tag. We use minimum amount of tags are 2, maximum are 50 or 1,000, something like that. There is a limitation for tags, number of tags. I don't remember actual limitation. Like I think 50 is a limitation. the QT trend, but it's easy to do. You could use a GUI uh, or or program interface to do that. Any questions, comments? Okay, let's move to next part, and it's about machine learning. And before that, there is a couple of things as a developer you must know if you want to make your application smarter. There's cognitive. Second bullet point is cognitive service. So you've seen it already. Someone of you using already, but I encourage you to look at Word2Vec. If you're not familiar with that, look at it. It's very important concept. If you build some knowledge content. Then there are some additional services like personality chat from Microsoft, where you will get the uh, something like language understanding only with different personalities, like happy answer, sad answer, professional answer, and so on. It's more for chatbots. Natural language processing, translation. We looked at it, and knowledge base. We'll look at it little bit later in one of the next examples. And let's go to Azure Machine Learning Studio. Couple of words about machine learning. Usually, it overlaps a lot with statistics, and NLP stays for natural language processing, and some of AI also is a just machine learning technique. And of course, machine learning is a approach where we, without coding, could extract these correlations between data. If we look how it started, started with expert systems, and we get the expert systems before machine learning. And for expert systems, we needed to provide all the rules. We needed to provide all if and thens, but machine learning could detect it automatically. And there's some techniques of machine learning. You see there is a clustering machine learning techniques, um classification, association, simulation, time series analysis, where the machine learning is very good currently. There are some different algorithms that could really very are very accurate with forecasting, regression analysis, and so on. And let's look at the example. Imagine that you have a data like this. So this is trading data, and you want to predict a stock price. You say, I want to predict stock price. And if you don't use machine learning, what you actually need to write a rules. You say, if a day of the week is Wednesday, then price probably will go up. If the day since price release is larger than 4, then probably go down, and so on. And you need to provide a lot of rules. Yeah, you can do it, it's possible, but when you have a lot larger data set with larger amount of columns or rows, it's hard to do. Instead of that, machine learning could find all these if and thens automatically. Some examples of very well where machine learning works very well. For example, determine chemical ingredients for steel production. Imagine that, and where it's needed, the most of the steel and nowadays is produced from the uh, secondly used steel, not from the ore steel or from the ore, but from the uh, yeah, recycle steel. And you need to, for each time, because there's different ingredients, you need to put different chemicals to the to this formula to to get the best quality steel. So machine learning could uh, say what kind of chemicals you need in each time, take in each time. Or there's another example when the machine learning algorithms could predict uh, how you need to communicate with your clients or partners to sell more. And there is example from Microsoft. Microsoft analyzed communication between sales managers and and the clients and say that if you spend so much time each month with this client, he will buy more. So they calculated it. How it works actually? We take this data model feed. We take this data where we want to predict, for example, stock price, feed in a machine learning model, and we will have a prediction. We provide it's when it's trained. There's a prediction service. We take a data without this price, stock price, and it will return us probable stock price with some probability level. Depends on model. There are three types of machine learning: supervised, when you provide labeled data. For example, you provide if you want to train a model to predict a used car price, you need to have a database with the cars as the records in a rows and the car price. If you want to predict some cats, you need a cat photos with a label cat, that is his cat. And there is unsupervised learning when you don't need a label data, and the most popular is a cluster analysis or market basket analysis, and we will look at this example shortly. And cluster analysis, like you just provide the data points and it will mathematically build the clusters. And the third type is a reinforcement learning, when you after each learning phase you provide some additional information about success or failure, and actually algorithms tries to figure out uh, what to do, how the result should be optimized to get the success rate. And there's like first chart is about supervised learning and the clustering as unsupervised learning. Talking about algorithms, and you need to know what to algorithm use in which case. And there's some cheat sheets from Microsoft, and you could see like you are starting on start and say I want to for example, finding unusual data points. So then we go to anomaly detection and use on class SVM, support vector machine, or PCA based anomaly detection. And another cheat sheet from Microsoft Azure Machine Learning Services, that we see that if we start and we want to predict future data points, no k-means and clustering, straight to the clustering. So there are different ways how to find the best algorithm to use. There becoming popular approach to use AutoML, automatic machine learning, which actually try a lot of models and suggest which of them is the best for you. Okay, and before we go to the machine learning example, let's look at the market basket analysis. And I will show the short presentation about a couple of slides about market basket analysis. Yeah, and then we will look at the R. We will show the R example, and will be custom model with R. And if we look, if we look at market basket analysis, it actually works like this in Amazon. When you buy something, it says that, oh, probably you want also this. You buy a nice T-shirt, and it suggests you maybe you want to buy a socks or book or knife. Joking. And yeah, we see the couple of cases. There's the upsells, cross sales. It's for e-commerce. Yeah, and we will look at the e-commerce recommendation case. For example, imagine that you have in basket 4 items, and it could recommend some additional items to buy. And we will use this association analysis model, market basket analysis, shortly MBA. And how it works, we will skip it. We will use our server, our language to run that, not our server. But if we talk about where we could run our scripts, there is a couple of ways how we could do it in cloud. But if we go on premise, then it's built in Microsoft SQL Server. We could run it easily here. And there is in a newer version, is SQL Server 2017. There is machine learning services that we could use running R and Python scripts. We could use a lot of different scenarios. For example, use transact SQL to run it from the stored procedure, for example. And we could run separately, and it's tuned for high performance, like using SQL Server, and Column Storm, for example, for input data. You could achieve performance of 1 million predictions per second. So that is when you have the data and R in one database. And there are different ways how to run it, but we'll look at that R. Are you familiar with R? Are you using R? Yeah, who is using R? A couple of persons. So R is a language created by statisticians, for statisticians. So it's not very handy for developers. It's a little bit stressful. It's easy to use. There's as an IDE is R Studio, most popular IDE, and the most beautiful thing about R is that you have 15,000 free packages that you could use. And today also we will show how to use MBA package. So we are not programming a lot. We just call one of these packages that are built by scientists, usually that scientists build these packages, so they are scientifically correct and proved, so it's easy to use. Market basket analysis. What we will do, we will repeat this recommendation scenario. What we will get the ordered, we will use the order details and create rules. And then after these rules, the idea is that we use a historic basket and order data, generate the table of rules using market basket analysis, and then use an application that actually shows you individual prediction for content. Okay, let's switch our.
Yep. So we're going to go backwards. I'm going to show the resulting product that you can use, and then I'm going to go back to how would you make that. So there is a simple macro in Excel that is using the generated recommendations. And if in our basket we have, for example, let's choose something else. Let's choose, for example, like a calculator, or no, let's say choose like one thing.
Yeah, this is example of,
for example,
office supply store. So you could also
oh,
have.
here you go, T.
Yeah, T. If you choose
Yeah.
T,
So,
it will recommend you.
So yes, you can see coffee, milk and sugar, washing supplies. So yeah, more of some kitchen supplies. Yeah, sticky notes might be an outlier, but again, there is a reason for that.
Good, Alex. Remember,
of course.
The sticky notes is so good for fast tasks. If you just write a fast task. Only thing with sticky notes is that after half a year, the glue like stopped working.
So yeah, basically on the left hand side we have the basket, which is the set of products that you have chosen in the e-commerce platform, and on the right hand side we have what is recommended for that. Yeah, for ballpoint pens, it's recommends sticky notes, notebooks, and yes, sticky notes. So and behind the scenes it works like that. A lot of rules were generated here. You can see the first million. There is a lot more than that. I believe the last model for me generated about 20 million rules. And a rule is basically, it consists of a left-hand side and a right-hand side and the rank. And so the left-hand side is the product that is in the basket, and the right-hand side is the product that should be recommended and which is more frequently bought with an item in the left-hand side. And each of the rules is recommended with the some rank, which here, if you're interested, it is a relative lift within an added constant. And yeah, so you can see that there are things. There are recommendations like tea, coffee, coffee, tea. All of them are work vice versa. If you have like laser, I believe that's a laser printer, then inkjet, and if inkjet, then a laser printer. And there is, yes, I said, a million of those. And of course, if you go like near the end, it is also a bit later. I'm going to tell about a little problem that we had. The problem with data, why it was a bit harder to do that problem. Here you can see RStudio. I'm not going to explain the whole code, but conceptually, what we do is we load the data set, and the data set consists of an item in the basket of a particular client, a date, a price, and a quantity. And then we're using those items to compose transactions. Transaction is basically one one deal. So basically, one person at one time bought 10 packages of printer paper. That's going to be a single transaction. And then we're modeling rules using different parameters. So, for example, minimum count of occurrences necessary to count that transaction, a lower bound for confidence, maximum length of the rule, so that it wouldn't recommend stuff based on, for example, 20 items in a basket, because that wouldn't be so accurate. Then a little bit of data transformation here to get it in the right format, get it in the data frame, construct the left-hand side and the right-hand side, filter out rules that have a big lift and too many occurrences. And again, lift is like a precision metric for this task. Lift is basically what is the how much more likely is the given set of items will be chosen than if it would be chosen randomly. So, for example, for tea and coffee, that lift is going to be quite big, because the probability that tea and coffee would be taken together is a lot bigger than if they would be taken randomly. And that goes for everything that is frequently bought together. And basically, what is happening here in the model rules part is the algorithm is trying to find all of the occurrences of the most frequently bought items, and constructs rules from them. And then in the end, we're trying to, here we're calculating some metrics, taking a subset of the rules, and in the end we're generating a data set that looks like that. But of course, there are some problems with that. I just wanted to show one of them, because I think that it's quite self-explanatory on one hand, if that's going to load.
The beauty of this is that you understand that it is market basket analysis. Actually, this code, you could just find it on the internet already. Just copy paste and start using. So because you don't need to train anything, you don't need to do anything. You can just use this algorithm.
Yeah, so what I have wanted to show, so that's a histogram of all the categories that are bought in the on the platform that we were doing that project with. And you can see that the first item is unnecessarily larger than every other one, and that item is bought like tens and hundreds of thousands of times, and that item is printer paper. And what that does to the model, because printer paper is bought basically with every transaction that happened on the site, the algorithm thinks that printer paper just fits so well together with every other item, which is not the case, and it just recommends printer paper to everything. And yeah, so you can see the distribution here is you can't really see the distribution quite well, because the printer paper is overwhelmingly larger. But if we take it out of the data set, yeah, we can see the distribution a little bit better. But again, you can see that the second most bought item, which is inkjet for printers, also is a lot bigger than the all of the other ones. Those are just some types of problems that you have to deal with as a machine learning developer, because data is not always going to be clean. And for example, we had really clean data, but that is an outlier that a little bit made the analysis a little bit harder. And of course, you have to think of ways to lessen the impact of things like that. Yeah. So in the end, yeah, we have skipped, I believe, one or two top items because they were just messing up the whole model and the rules. Yeah. And in the end, yes, you have around 15, 20 million recommendations, but rules, but you don't need that much. I can say that you probably be better off with 100,000, and that's going to be enough for almost almost every situation.
Yeah, and actually, if you want to build a prediction, what to suggest, like buy this together with this, that, you don't need a live machine learning model. So you just need to request and ask for prediction. You could use this result table and just load it anywhere. It's very easy to do it with R. Okay, let's make another break for 5 or 10 minutes, and then we'll continue. Okay. Any questions so far? So just 50 slides left and a couple of demos. So I think we will finish before 11. Don't worry. Oh no, it will be before 8. We will finish before 8. So let's look how to build, understand actually build machine learning modeling. And if you build some model, maybe it's understandable and easy. But if you didn't, then this will be very useful for you. So any model, if you look at a cow model, is constructed. We start with some data, then we do the data cleaning. And for machine learning, and when we start with the data in machine learning case, it's always one table. There is no relational model or something like that. That's in one table, and we need to clean data. Uh, uh, and machine learning requires very clean data, very good data. It means no missing values, no missing values in rows or columns, and so on. And the data should be very clean. Then we use some portion of the data for training, like usually 70%. We use some algorithm for training. It depends. Remember this cheat sheets for algorithms. And then we do a score model using the other 30% of data. The idea behind that is, imagine that you use some kind of portion of data, you do a model training, and now you want to score and evaluate data. You want to understand how accurate this model is. So you need to show some data that model didn't see. So that is why you split the data and use this 30% for scoring and evaluation. And that is how model looks like. There is a famous example from Microsoft. Would you survive on Titanic? And it used Titanic data, and there is a model built in Azure Machine Learning Studio. You see that we use a Titanic 3 CSV, then clean data, split it, do some partition, and then train model using two-class decision jungle, and then evaluate and score. And let's look at this model. Yeah, and that is how this model looks at machine learning, Azure Machine Learning Studio. And let's look at the how application built from this Titanic data set and machine learning model. Let's use this link. And there is a specific application. What we have here what we have here. We could provide that some input parameters like first class, second class, male, female, uh, how old are you, how many siblings, parents and children, and the ticket price, and the and which port you like you are come from. And actually, we could generate a set of data that algorithm didn't see, and will predict the probability that you will survive. And let's do some, like I will choose second class, male, how old? Please help me. Like 40, no siblings, no parents, ticket price like 260 uh, Queenstown. And now, before I press submit, what do you think? This person from second class, what is probability for him to survive on Titanic? 20%, 40, 41. Okay, sorry. Submit. 0. 0.4, 0.5. And if I change to just gender to female, what will be a probability? 99%. Okay, different setup. First class, third class. Third class male, same, a little bit lower price tag. 24, 22, and so on. So that is how this um, like using this data. Of course, now playing with this, you could say, oh no, it can't be. There is something wrong, or you could figure out it. But it is how from the larger data set we could predict it. And let's build our own machine learning model using Azure Machine Learning Studio. And what we will, you could follow if you want. You could follow now. Right in the browser Azure Machine Learning Studio, and you will find Studio Azure ML.net. You will see that kind of screen, and for to for you to be to easier to use it easier, so just click here, sign up here, and use this 8-hour trial. You see that there is 8-hour trial. It you could use it without any registration, without anything. So just click enter and start use, and you could follow. There's some features will not work, but you will don't need them. You could also subscribe, as I'm doing, for zero, so for free workspace, when you could save your projects and could run them as a web services. And I will log in into it to show you when we build, after we build this model, how to publish it as a web service and use it from Python code. Yeah, who will follow? Is anyone who will try to build the model? One? Okay, no problem. So you open Azure Machine Learning Studio, and it's a web interface for everything you have. Like here, my models, and here you have a notebooks, data sets. You could upload your data set. There's a web services and things like that. And let's start. We will start with experiment, and you could build. I click new experiment. You could start from the blank experiment and use some pre-built experiments. There are a lot of them, but we will go through the blank experiment. And we will build experiment where we will predict a used car price. You see there's a lot of different elements, like you could add R script here or Python script or different data transformations. We'll build a model. There is a uploaded data set called automobile car data. I just drag and drop it, and you see there is a automobile data price data set. I click here on to explore this data set. say visualize, and I could see that actually what kind of data have here. There's I see that there are missing values in normalized losses. Oh, that's not good. There's a make. We could see some statistics like distribution, number of missing values, and there's different things. And there's a price that is labeled that we will want to predict. First, we will just clean some data, and I will use a column selector, and I will say select columns in data set. I just put it here, and say that it's linked. And now I will click on this and select needed columns. So what I want to do, I will filter out this column normalized losses. So I say put it, so let's exclude it. I run the model, click run. Actually what to do, it performs the activity I put here. So it's done. Let's look at it. And if you look, so there is no any more column normalized losses. Okay, that's good. Next, clean data. I will clean data, and I write a clean missing data. There's a uh, functionality for that functional block. I just again link it, and I will provide some part cleaning mode. I will say that remove if there is a empty field. Let's remove entire row. In my case, it's fine, and I run it again. So now it will clean up this data. Now I have a clean data, and let's select data I will use for prediction. So not all the columns are needed to avoid some uh, overfitting. I will select column and data set, and we'll say what columns I will use. I will use make for prediction, for fuel type. I think body style, not drive wheels, engine location, wheelbase with um, engine type. Yeah, let's use it. Engine size, yes. Fuel system, horsepower, it needed peak RPM, city, MPG, highway, and price. So I choose what else? Body style, maybe. Okay. Now running it again. We will select needed columns for my model. And sometimes now it runs quite fast, but sometimes it could take even hours. If you have a large data set or complex transformations, it could run quite long, and it's okay. Now, as you remember, when we have the cleaned data, we will split it. And I use a split data function here. And you see that there is a splitting amount. I will say that let's use split 70%, 70 to 30. Now my data is cleaned and splitted, so I'm ready to train my model. And now I use train model. Train model, I place it here. Now I use this 17% of data. I could look at it, how it's splitted. There are some split parameters, how I could split it. And now I say train model, and I need to choose what I want to predict. I'm going to say, I want to predict a price. And now I need to provide the algorithm. In this case, let's use just linear regression. Very simple algorithm, but works fine. And now I have this model trained with linear regression. I'll not adjust anything. Let's just run it. It takes some 10 seconds to train this model. it's ready, and score model. So we will get our values. So we just results from the training model and use this 30% of test data. Now we can compare uh, in original how we could look at the predictions of this test data. So model scored, we say visualize, and now if we look here, we see the price, its original price, and there is a scored label for data model didn't see, and we see that what is difference. So looking here, we say that for Toyota hatchback, la la la, price from the training set is from the test set is 8,000, a little bit more, and the score is 6,500, huh? Maybe Dodge, Nissan, and so on. And we want to just evaluate accuracy of this model, and we could use some standard metrics. We will use a evaluate model and look at accuracy metrics. There are different accuracy metrics for different algorithms. In case of linear regression, we could look at root squared mean error, root mean square error. And we see that coefficient of determination, we could say that this is something like accuracy is 89%, and root mean square error is 2,700. It means that the error could be plus minus to 2.7 thousand. Well, let's look at this metric, RMSE 2007, and let's try different algorithm. We say that linear regression is not good enough. Let's try another one. So, any suggestions? Algorithm gurus? Let's try some forest. Two-class logistic regression. Bayesian linear regression. Okay, let's try this one. Now I just delete this and add, but you could build a multi-algorithm here, put many algorithms and try them out in same time. It takes, yeah. Let's look at it. It looks a little bit different because algorithm is different, but let's look at root mean square error again. And it's pretty the same, so even worse a little bit, I think. Plus minus, yeah. So, but okay, we will not play with that anymore. So we are ready. We say it's okay to use it. And now you build this model in free environment, and you want to use it in your application, right? And let's look how to use it. I will give a name, development community for Alex. It's for you model because high error. And save. I save it, and now I need to deploy it as a web service. I will say that let's run it again, and we will deploy it as a web service. So it's ready. And when we deploy, we start to deploy it as a web service. it creates input and endpoints, because at the end it's just a REST web service with an endpoint. We need to run it again, I think. And it creates, because it need to replace we need to replace our input data with web service. And now I'm deploying it, just publishing as a web service, and now it's ready. So we can now, so it's as a web service, and we could test it from our application. So what you need from me? API key
and
only,
the endpoint.
an endpoint. So I will uh, I will send endpoint and key to Alex, and he will uh, run a test from Python code. Stop sharing. Now you could share. I'm sending you API key and endpoint.
Yeah, about the script. So again, nothing special. Nothing is happening here except for us constructing the dictionary here called data with the input. Here we have the attributes for a single car, and yeah, in a special format. So we have an element inputs, which also has a dictionary input one, which has a list of cars, but we are using only a single one. Then we're going to put that object in our request that we are going to send once we have the endpoint, and yep, then we are going to try to open up the request and hopefully see the response. Sorry, and hopefully see.
So you could use old endpoint and
I can
yeah,
see the
use one.
Okay. Okay, so from the beginning, the libraries, the car data, the keys, and the endpoint. Okay, let's try. Okay, the request failed. Looks like the endpoint doesn't work. US South Central.
With you changed the key.
The key, yes.
You need so you need to another one. We'll send you this one.
Okay, try number two. Yep, here we go, and we're going to print it a little bit more pretty. Yeah, so the API returned this Alfa Romero, yeah, with a certain specification and the price of 13,000 and the scored label of also 13.
Maybe change some of input parameters and see how it will influence the price.
Yep. Okay. Let's try to. I don't know the horsepowers. Yep. I don't really like the low horsepower. So let's try to do that.
So the previous price was with the 100 horsepower powers
13,000.
13,000. So what do you think? If we change horsepowers to 300, it will increase price or not so much? Increase. Okay.
It seems like that. Okay. Oh no, 300 is going to be enough. Okay. So let's go. What do we see? Oh. Yep. Score label 26,000.
Oh.
Yeah, and yeah, you also can see that the relationship is not linear because we have increased the horsepowers 3 times. The last time it was 100 something something, and we have increased it almost 3 times to 300. But the price did not increase also 3 times. The price increased only twice as much. That's because of the specific algorithm that was used, specific ML model that was used. Yep. So quite simple here, I guess. Any questions about that one?
Okay, let's move. And one, stop sharing.
Mm-hmm.
One interesting thing about this Azure machine learning stuff and models that you could use them directly in Excel. Do you know that? That you could just there is an add-in called uh, Azure Machine Learning, and you imagine that you have Excel table with your data, and you want to do some prediction here, and there is this you could add a web service. You just provide this data here, this link, the key and the stuff. For example, if we take this Titanic example, let's use some data, sample data. For example, you have a data with people, then you say that let's use it as a prediction and output. Let's put output in H22. And when you click predict, it sends data to Azure Machine Learning Model, and you get here you see that uh, label that 0 means not survived, 1 is survived, and there is exact probabilities. So you could build this model in Azure Machine Learning Studio and use in your Excel, so with your data. Sometimes Excel is also application. Okay, it's about machine learning. Two things left: Q&A Maker and Lewis. What is Q&A Maker? It's a service which is knowledge base, basically, and it allows you to extract frequently asked questions or data in a form that you have question and answer, that like question and answer pairs. And using natural language, you could mm, uh, ask in natural language questions, and it um, will return you your most probable answer from answers using full text search. And let's look how it works. There's a service qnamaker.ai. It requires it's free to sign in, but it requires a search service in Azure to create a search service in Azure. Currently, I don't have any knowledge base, and I say create a knowledge base. And first step one is create an search service in Azure. I click here, or I could create it separately, but I will follow instructions here. There's different two pricing tiers. Let's take this one for 50K documents, same resource group, location, upname. It's okay. Up in science and create. So we create this search, which also is a cognitive service. If you look at you will find it in cognitive services as a search. It will take a little bit to deploy it. And
Does the Q&A Maker support translation?
Not translation, but multi-language support. It means if we provide data in Latvian, it will make an indexing in Latvian. It supports many languages.
So that means basically, by the way, that you can use the machine translation API that was used before in order to translate the queries that the user is sending to the chatbot made, and then translate back the response that it receives from the Q&A maker. That's just one of the possibilities to do that.
Yeah, and it automatically will create this search index in a language in which you will provide the source data. While it's creating, let's find some frequently asked questions.
There is Microsoft frequently asked questions.
Let's look at them. Frequently asked questions from Microsoft about Windows and Windows and Office. We will try them. So I just copy. So my service is not ready yet. So what I will do when I create knowledge base, I could provide a link. It could be a URL when my questions and answers are, and it will extract the Q&A pairs from this link. Or I could provide multiple documents if I have it in Word or PDF. A couple of services. Let's wait. And we will try out this. Can it take, like, how do I find Windows product key? And there is a boom answer. It's creating.
Maybe while it's creating, we can go through other cognitive services that we're not going to go through, but just to show that they are available. Like for example,
Can you?
yeah, stop sharing them.
Like the most recent cognitive services are ink recognition, that handwriting recognition. Maybe you could just show it, or and form recognition.
Yeah, and also there is
When you can extract the data from some table form.
there is also quite a bit of cognitive services that are based on speech. Like for example, I have heard people were wondering about the speech to text services, and also the text to speech services available. Sadly, no support for Latvian language yet. But yeah, here you can see. So there, in 5 different categories, there are decision services, language, speech, vision, and web search. And the most interesting, I believe, would be so the language understanding we're going to show a bit later. Here is the Q&A maker. The text analytics is quite interesting. So basically, we are feeding the service some bits and pieces of text, like for example, like tweets in Twitter, yeah, and it is going to return to you different analytics about the that piece of text. For example, the sentiment was the tweet about something bad or good. What were the emotions of the people of the person that was writing it. It would extract keywords, and you can automate that process. So, for example, try to automate like feedback collection about your company, for example. So there are a lot of different ways to use that. Then there is the translation API. About speech, yes, speech to text, text to speech. That's also quite. Yeah, I can also see there is a speech translation, also quite useful for a lot of different scenarios.
Show this ink cognitive service.
Yeah, and also there is the one of the most recent one, there is the ink recognizer, and yep, so it works like that. So basically, yeah, if you have a digital tablet and a digital pen, then we can write something on the tablet. The this API receiving the handwritten text or handwritten shapes and forms is going to return to you the closest approximation of what it believes you have written. So basically, handwritten text. Uh, what do you call that? Handwritten text recognition and also form recognition. That also could be quite useful if you prefer, for example, writing with your hand and not typing on the keyboard, but you would also like to get your handwritten notes and whatnot digitally.
Okay, I'm ready.
Yep, that's it.
Yeah, so we are creating. I provide the Azure Q&A service to this form. Then I will give a name for this knowledge base. Then enable. I will give the URL here, and their chit chat could be available, like professional friendly. This emotion, this personality, but I will not provide it. Just create this knowledge base. So now it takes this link and try to extract the question and answers from this Microsoft frequently asked question page and create this knowledge base.
Has anyone tried the recently released SRS chatbot, the Toms, I believe? Nobody. Yeah, so
SRS,
SRS.
State Revenue Service.
Yeah, I was meaning vid, respectively, valsts DNS. Okay, yeah. So just recently they released their own on, online consulting. I don't think we want that. If you're interested, yeah, we can try that at home.
So let's look something. So we have the knowledge base. We open it, and here you see that it extracted. Actually, you see that what is the we see what is the difference between 32 bits and 64 bits version. Yeah, it extracted all these question and answers from this page. Now let's save and train it. So we just did a full indexing, and now I want to test it. We could test it here, and I could test. Remember something about license key, and it's not necessary for me to write it in the same way. I could just say normally I could add where I lost my license key. Not got good thing to do. And now it tries to find the most appropriate, and it finds this one. I could click inspect, and it shows me that probability confidence score for this answer is 34, and there is a several other options. For example, this a product key comes with the Microsoft Office product. I say this is a better, so I could choose, but this is a less score. I think it's better, so I could force visit and say that use this one as a answer. And if I want, I even could create my own. Like I will say, let's create additional pair. I will say, if someone asks who is best Python developer? And answer will be Alex. Just for today. Yeah, save and train. And now, Alex, we will try to connect to this and ask a question about. I will say publish. So I'm ready to publish it. So it's trained. It's fulfilled. And again, we want to run it from our application. Here is a request information. So I just, yeah, this one you need,
Uh,
or Carl.
I believe, yeah, better. I believe we did not make that yesterday.
Oh, no, we tried it out. Remember?
Yes, but you have. Okay, let's try that again. But just send the whole. Yeah, that was no.
We could create bot. Of course, usually it's used for chatbots because it's easy to create a knowledge base that we could use, and it it will look very intelligent from the first time you created it. And you could then you could add some tags and additional information, multiple questions. You could fine tune, add additional things, and so on. So it works pretty well. Yeah, and currently we are using this English version because we provided the English. So you can't mix actually different language here. You need use to one language, but using translation services, you could get this multi-language version. So, how far you are? I will test it here. So skip. So you get the idea that from the code you will just provide this question and you will get the answer with probability. I will ask, I need best Python developer. So I'm not asking who is the best Python developer. I say I need the best Python developer, and the answer is Alex. Let's look at the probability. 38. Okay. Let's try. If I will write just Python developer, and it again gives the Alex as a name with a 47. So score. Okay, that is how the Q&A works. And let's look at the last service, and it's LUIS. LUIS is a natural language understanding service. It's how we could build the logic for fully functional chatbots. It's a service called LUIS, LUIS.ai. And I have the idea is that, for example, that you could build a model that which from the text you provide could detect intent of what you are talking about and entity. For example, you could build a model for flight ticket booking, when you could understand how to extract from the ticket from city to city, and things like that. How it works, I have a couple of slides. Let's look at if it will help us or not. Okay, not much. Let's start with demo. Let's migrate. No, I'm joking. And for example, you could create these applications. Here is a service desk application. And in service desk application, what we have, oy, oy, oy. Yeah, what we have four intents. We have a change. Imagine that if I write something, it could, and as a service desk chatbot, you need to understand: is it? Are we talking about change password? And if yes, then I do some activities. None. Ticket status, user access, or we could create our new intent. But let's look at change password intent, how it's constructed. Actually, what we do, we provide utterances. And here, utterances means we provide the common sentences that are usually goes together with this intent. And you see that there is a username. In original, there is a reset utterance called reset password for user Mike. Yeah? And we mark it as an entity. So we say that this is a it is a this is not it's a username. Like if I add uterance, another uterance, I will say I'll just say add um, where is password for user Alex. Yeah, I add this, and you see that it automatically detects that Alex is this entity. But sometimes I need to provide it. You see there I could there's some some entities, and I could say that this is that kind of entity. And how it works, if we look at we could just test it, and we could say something. There is untrained utterance, but let's skip it. I want to change my password. Yeah, and it will provide the change password is 97%. That this is change password. Uh, New password for user Alex, and we see that there is a change password, 92% confidence, and Alex is detected as a username. So what you will have in JSON file, you will see that um, entity is Alex as a username detected, and intent is change password 92% probability. And let's create new intent. For example, if this is a service desk, what kind of intent could be? What kind of intent we want to detect from? What the people are asking?
Forgotten passwords.
Yeah, yeah, it's already here.
Um,
Let's
New tickets,
new ticket status is here.
but filing a new ticket.
No, 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 something more original. Mm, what?
Locked account.
Locked account. Okay, and we want to detect that we are talking about locked account, and we could provide any name. We account. We'll say locket. Yeah, that is our name intent. The intent will be that if we will imagine that you have application, and then you have this Lewis model. You send some uterance, some sentence to Lewis, and you will get back intents, list of intents with probability. You will take the highest probability intent. In this case, it will be account locked. And then you will write some logic like if account locked, then do this, send bomb to blah, blah, blah. Okay, and let's provide some uterances. uh, how how to understand. Usually, you need to provide, let's say, for good intents, you need to provide at least 50 uterances, 50, so 50. So it's quite a lot. So it's not about 5 or 7 uterances that could work fine, especially if you have a lot of intents. In this case, huh, I uh, I did something wrong, and now I can't get into my laptop. Sounds realistic? Let's have it. My account is locked. What you did with my account? You please unlock my my account, and so on. So we provide utterances. Now let's train it, so we could test it. Blum 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 blum. It's tested. Now let's test it. Alex, any ideas? That is not overlapping with this. Hi, uh, I am Alex,
I'm a Python developer.
and my seems my account is locked. And you see that account locked intent is 86 probability. And what we could ask that is not without any words account and without word locked.
Cannot sign in.
Or and now it's none, so it's not detected. Okay, any questions? The last slide. So there is a if you build chatbots on conversation things, that there is a conversation learner product or functionality from Microsoft that is something like bot, not bot trainer, but that helps you to work with larger amount of trained data for chatbots, and could optimize the chatbot logic. So, and our model is, so what what we what we learned today. So we look at the general things, how the AI is going on. So it's not perfect. It's quite, remember that it's narrow. We are in narrow AI era. It means that AI could do one thing quite good, but not many things. There is no, we are far away from general artificial intelligence, not in our lifetime, probably. And it's because the current technology, state of the art technology, neural networks, is not capable to build. It's not possible to build GAI with the neural networks. And so be careful with that. But still, we are very optimistic about what we have. Cognitive skills, that is that could recognize and could detect, is it dog or muffin? Remember the translator and other services. And then I think the most promising thing currently is how to extract and store knowledge. And we'll look at the different services like Azure Machine Learning Service, Q&A Maker, natural language processing. So that's it for today. Thank you to be here. And if you have any questions, we will be here 7 minutes. Okay, a little bit more, so you could come and ask any questions. Thank you very much.